Hello everyone. Thank you for being here. Today we are going to talk about collaborative CAD and GIS in JupyterLab. I am Arjun Verma, and joining me is Martin Renou, who is a technical director at QuantStack, and I am a scientific software developer at QuantStack only. I'll just start with the question first. So how many of you know about FreeCAD or QGIS? Okay, so I see a lot of hands. So it would be easy for me, but for those of you who do not know about either FreeCAD or QGIS, let me just tell you a little bit about them. So both of these tools are very powerful. Both of these tools are desktop based and they provide a lot of utility in their domains. FreeCAD is a go-to tool for 3D modeling, 2D modeling, design, architecture, and all. And QGIS is your go-to tool for all the geospatial data, geospatial analysis, and GIS editing and stuff. These tools are really powerful and they provide a lot of utility, but they come with some pain points. So let's just talk about what are the things that are painful for the users of these tools. So both of these tools are very big in size. They take a lot of storage space and they take a lot of computation on your machine. And yeah, they are very slow to install as well. And although they come with a lot of utility, but that utility come with a cost. You see that there are 3 toolbars on each tool, and it is quite overwhelming for beginners. And if I am working as a beginner with these tools, I would definitely be overwhelmed in the start, and I would definitely need some tutorials and some videos to get help. These tools are not collaborative. So GIS and CAD files are still shared over emails, Git or drives, and it is very difficult to iterate over them. And when you are working on a task that is multi-person, it creates a lot of friction between people. And when you are working with the scientific Python ecosystem or any scientific environment, you have to do a lot of context switching between these tools and your work environment. So you are going back to QGIS for visualization, then you are doing processing and come back to Jupyter, and yeah, then you are going back again to QGIS. So it breaks your momentum, obviously. And finally, these files are also not easily shareable. So if I'm working on a version of QGIS and you are also working on a separate version of QGIS, it is very possible that I share a file with you and it would not work for you. And yeah, you would be like this only. So what if there is a tool which comes with very small to no install and very non-overwhelming and beginner-friendly UI, and also with live collaboration support and is inside your notebook and you're close to your scientific work environment and is interoperable across tools and formats, so you can import and export many types of file and data across tools, and is very highly extensible, so you can integrate your favorite tools, libraries, and modules with the tool and use them seamlessly. So introducing JupyterCAD and JupyterGIS. So let's just talk a little bit about JupyterCAD first. So JupyterCAD is browser native 3D modeling for JupyterLab, and it is built on OpenCascade and which is compiled via WebAssembly, and it uses Three.js for viewport and rendering. It provides you the utility of parametric and sketch-driven design inside your notebooks, and you can also use it separately in our own UI that we have designed. And it integrates very well with Python and code cells. So when you open JupyterCAD, you would see a screen like this. So this is a live demo embedded in JupyterLite, embedded in iframe and deploy with the JupyterLite. So you can create all types of basic shapes. You can create a box like this and a cylinder. Maybe I would give it some height. And I can perform some operations as well. So if I select the box and select this cut operation, and I want to cut my box with the cylinder, so I would Maybe also give it a nice color. And you see a box has been cut with the cylinder. There's a void that's been created. And I can also do some geometrical operations as well, like this fillet. I can select an edge, and a radius. I would keep this color same, and I would submit it. So you see, my edge has been smoothened. You can create a lot of shapes using these operations. This is a nice example. And we also have so many views in JupyterCAD. So we first have this exploded view, which comes with, which comes with a slider. So you have this slider to change the exploding factor. You can move the slider to see the every part of the object that you are working with. We also have this clip plane view, which lets you see through the object and cut the visibility of the object using this clip plane. We also have the wireframe view, which lets you see the object in wireframe mode. You see that you can see all the wire objects, all the lines the object has been created with. And we also have transform controls. So you see that I cannot carry this screwdriver in my bag. So what I would do, I would select the tip of the screwdriver and enable transform controls. We have this snap value to change the snap value while moving an object. I would just remove the tip. And now I can safely keep it inside my bag. And we also have Python API for JupyterCAD. So you can, we have an integrated console. So I just wrote some code here to create a gear, and you see that gear has been created. And all of this, we have also integrated JupyterCAD with the notebook cell output. So you can directly work inside the notebook, and you can interact with the Python API to create, modify, or play with an object. Similar code to create a gear, and yep. So JupyterCAD comes with collaborative editing. Similar to Google Docs, you can work with multiple people on a same thing, and you can see what the other user is doing. We have follow mode. It uses PyCRDT and YJS models to enable seamless collaboration between users. And if I change the any property of the object, it would reflect to the other user on real time, and you can do meaningful collaboration between multiple people. And we also have suggestion workflow. So similar to GitHub pull requests, multiple collaborators can work on the same thing asynchronously as well. So I can create a suggestion. So in left, I am creating some voids and also change the color of the model. So I'm creating 2 more voids in the pad, and I would create a suggestion. Maybe I can fasten up the video a little. So I have created 1 more void in the bottom left corner. And now the user in the right could see that what I have done and what I have suggested. And he can accept or reject the suggestion asynchronously. So in JupyterCAD, we have multiple file format support. We support FCSTD file, which is a FreeCAD native file format. So we can import or export or edit a FreeCAD file format inside JupyterCAD. And we can also create a JupyterCAD file and export it to FreeCAD. So you can work seamlessly with the people who are already used to these desktop-based tools like FreeCAD or QGIS. And you can, it provides a lot of seamless experience and utility. And we also have support for STL and STEP files, which are mostly used for 3D printing. So you can import a STL or STP files as JupyterCAD format. We have a simple format called .jcad, and you can import these files, edit them, and again export them back to STL or STP format and print them. And you can move between many tools without friction and with the support of all the usual CAD operations that you have in other tools. And lastly, we are working on this proof of concept, which is JupyterCAD MCP. We are trying to integrate the LLM with our tool so that you can instruct the LLM to create your model and interact with it to make your create your object automatically. So in the left, I am interacting with the LLM to create a pawn, and you see that a pawn is being trying to create automatically by the LLM in the right. I would just tell it to make it a little better, so it would try, but currently it is not in a state to make it look very nice and very cool. So yeah, it is trying, but I guess it cannot still match humans right now. Yep. So this is all about JupyterCAD. Now my colleague Martin would join us to tell you more about JupyterGIS. Thank you.
Thank you, Arjun. So yeah, historically we started working on JupyterCAD first, and it was used as a good skeleton to start JupyterGIS next, or JupyterGIS. You can say both, I guess. So what is JupyterGIS? JupyterGIS is a fully collaborative GIS tool for JupyterLab. It supports raster and vector layers and multiple data types, and it's built using OpenLayers and GDAL. So I'll go directly to make demos. So this one is actually a record, but just to show you that it's fully collaborative, just like JupyterCAD that you just saw. So you can have multiple people working on the same file at the same time, editing the layers and loading the data, visualizing them, and it's all shared. It's working on the same file. So this one is a live demo, just to show you that in this document I loaded a GeoJSON vector dataset, some raster tile, the green and red one. I will hide it for now. So yeah, I have multiple layers. I can look into my data, and yeah. So you can load your data. We have a gallery of base maps that you can use for the background, and then you load your vector data on top of it. So we have advanced styling capabilities. So for example, here I loaded this earthquakes dataset. Okay, I need to go fast apparently. So I can edit the styling of this vector dataset based on the magnitude of the earthquakes. So let's select a color map, and yeah, so I can see that I guess these people are lucky, but these ones are less lucky with earthquakes. So you can see the color map and the legend here. We can also style raster datasets, not only vector datasets. So this one is cloud optimized GeoTIFF. So it doesn't load the full file at once, it only loads what I'm looking at right now. And I can style it the same way. So this is trying to mimic the symbology panel of QGIS. Trying, yeah, succeeding. So I can change the color map, for example. Yeah, this is all due to network. This is why the symbology panel was slow to load. It needs to look quickly into the dataset to try to see how it can style, depending on the data. and then it styles it. So yeah, it's cloud optimized GeoTIFF, but still depends on the network. You can load your layers, move them around. So this is like the top layer here is the top layer, the bottom layer is the bottom layer. So you can move them around and rearrange how you want. And hide them, change the opacity of layers, basic things like this. Yeah. Okay. We also have the identify panel, which allows you to identify your data. Let's say I want to know this earthquake, how it was. I can just identify it and see the magnitude and when it happened. We also have a time slider to see, to browse time-dependent data, which is cool. And of course, we have support for QGIS. So that was important to us to stay close, similar, just like JupyterCAD supports FreeCAD file format, we wanted to support QGIS. So you can import your QGIS files, open them, like here, and we can also export our in-house format to QGIS. We don't claim to support the full QGIS capabilities, of course, because it would be quite big, but simple projects can be exported easily. So just like JupyterCAD, we have collaboration capabilities, so everything is synced between users. We all see the same thing at the same time. We don't have suggestion support yet, but we would love to. Although you can add notes on the map and start discussing. Okay. And like JupyterCAD, we have a Python API also that you can use. So you can directly from the notebook, you can display your map and edit your project from Python. So you can do most of the things you can do from the UI. You can do it in scripting in Python. And the way it works actually is that Python works just like another collaborator in the collaborative editing sense. So yeah, it's like another person editing the file at the same time. And yeah, maybe I have time left. That's okay. We have processing capabilities. Yeah, 5 minutes left. So we have a GDAL compiled in WASM running in the page that allows us to do processing capabilities just like in QGIS. So for now we have these functions available. Like for the earthquake, the one that could make sense is buffer, which will show me an area of effect around the earthquakes. So let's compute it. And I'm hitting the demo effect, it doesn't work. So, yeah, it just takes time. So it shows up. So you can see the area of effect of earthquakes. And it was added as a new layer to the project. So your data are embedded in the project. We have a STAC browser, which was recently added by someone in that room, actually, which is not us. And so the STAC browser allows you to browse STAC catalogs using the STAC APIs. So yeah, it filters depending on the viewport. So if you zoom into France, you see the catalog results are updated, and you can add the STAC items to your map. And we also have another feature that was added by someone else from that room also, which is not us. The T-Tiler extension, it's a plugin to JupyterGIS that was created to allow using T-Tiler from Python in your kernel to serve your tiles to the project. So this needs a living kernel, and you can do advanced processing in Python to serve your tiles. So how does it work? JupyterCAD and JupyterGIS are both JupyterLab plugins. So when you install them, it just enhances the JupyterLab experience by adding new file format support for GIS and CAD. The collaboration support is done by using CRDTs, which is a way to resolve conflicts between changes between users. We do a lot of WebAssembly, but I'll come to that later. And we use OpenLayers for the visualization. So JupyterLite support. This is important to us. There is another thing which is really cool, and there is a presentation later at noon in this room, you should stay, about JupyterLite. So JupyterLite is another JupyterLab distribution that allows you to do everything client-side. It doesn't require a server to run the Python kernel. Actually, the Python kernel runs in your web page. So this makes it really easy to deploy. You can deploy in read the docs next to your documentation to showcase your library. You can deploy on GitHub pages, your notebooks, and those can run easily. At QuantStack, we maintain mscript and Forge, which is a Conda Forge distribution for JupyterLite that allows you accessing many packages like Matplotlib, NumPy, scikit-learn for JupyterLite. So all demos that we made today, the live demos that were working, thankfully, those were embedded in the slides using JupyterLite, actually, and this is deployed on GitHub pages. So yeah, you see it works. So many use cases, just like for QGIS, but I guess what is easier for us is the education and integration with Jupyter, which makes it quite nice. And the collaborative editing is also super nice. So we have many ideas for what's next for JupyterGIS. We would like to make an MCP extension as well, just like for JupyterCAD. We would be close to it, I guess. We would love to build story maps. So the idea we have with story maps would be to make documents that tell a story around your data, where you would browse the story. It would move around the map and show you information about your data. And many other ideas. So if you also have some ideas, please come and talk to us later. The initial work on JupyterGIS was made by QuantStack and Similar Research Lab and funded by ESA. And the Stack browser and T-Tyler extension were funded by CNES, thankfully. And we also work a lot with DSE from San Francisco, sorry. So it's not only us at QuantStack, it's a whole community behind it, the GeoJupyter community. So you can join us. We have hackathons bi-weekly. You can come and share your use cases, share your ideas. You're welcome. And I guess that's it. So if you have any question, please go ahead. And you have QR codes to the repos if you want to check it out.
Thank you, Martin and Arjun. We have some time for questions.
Can I? Congratulations. Maybe a stupid question. Why you use OpenLayers and not IPy leaflet?
Why not IPy leaflet? So we don't have a kernel running, so we cannot use IPy leaflet per se. We could have used leaflet.js. The reason we went for OpenLayers is that OpenLayers has native support for cloud-optimized GeoTIFF, which leaflet.js doesn't have. And among other things, we had many discussions about this. But another discussion we had was have a way maybe, well, for the future, I don't know if this will happen, but whatever, if we want to have 3D support, OpenLayers doesn't have, but other libraries have 3D support. So we've been thinking about having multiple viewers for JupyterGIS, where you could switch depending on the project and the needs of the project between viewers. So leaflet.js in that case could be an option. Yeah.
Thanks.
Thank you for the talk. Do you have a roadmap for both projects? A public one?
We have lots of ideas. We don't have a roadmap set in stone. Yeah, we have ideas, and we welcome ideas as well.
Hi, I was going to ask, how does the JupyterCAD API compare to, I don't know, Build123D or CAD Query, other like 3D APIs?
So JupyterCAD is document-based and collaborative. So we evolve around our file format that is collaborative. So it's really backed by a file that you can save and share, and yeah, and it's not only for the notebook. I don't know for CAD Query, but I guess you can only use it in the notebook for visualization, and it's the file then is the notebook, but it's not a CAD file. Yeah.
All right, cool, thanks.
We still have some time. So could you probably show cases where JupyterGIS has been used for research? I think there was one project, quite impressive one. Otherwise, you can mention it.
Yeah, there is something we could show you, but I would need to find the link. Sorry, I was speaking French to you. Yeah, we do have one about. That was a research paper that came out not so long ago about CO2 storage capabilities, and we made this nice demo where you could identify each places to see the CO2 storage capabilities, and this was a paper published on Nature. So this is a demo we made. Thank you for the question.
So thank you, Martin and Arjun.
Thank you.
And so please applause them once again.